Top 10 of things to be considered when operating a differential spectral responsivity facility. Number 10. The monochromatic light source. For the DSR method, you need narrow-band monochromatic light in a wide spectral range from at least 280 nanometers to at least 1200 nanometers. It can be useful to have different light sources to be coupled into the monochromator. You can use a xenon high-pressure arc lamp for the ultraviolet and visible spectral range and a halogen lamp for the visible and infrared spectral range. Make sure that the light is properly coupled into the monochromator. Number 9. Chopper. The DSR method is a two-beam technique where the device under test is exposed to monochromatic light and white bias light. The monochromatic light is chopped, and lock-in technique is applied. It is advised to place the chopper in front of the monochromator. If it is placed behind the monochromator, diffuse bias light could be reflected on the chopper wheel, leading to falsification of the measurement. Number 8. Diffraction order filters. In a grating-based monochromator, higher diffraction orders can pass. An example: if the monochromator is set to 1200 nanometers, also radiation with the wavelength 600 nanometers, 400 nanometers, and 300 nanometers will be emitted. This would lead to a falsification of the measurement. Therefore, it is advised to place high-pass optical filters behind the monochromator to suppress the unwanted higher diffraction orders. Number 7. Monitor principle. In a DSR facility, the device under test and the reference device are usually measured subsequently. A drift of the monochromatic spectral irradiance between these two measurements would lead to a falsification of the measurement. Therefore, it is advised to apply the monitor principle. A fraction of the monochromatic light is coupled onto a monitor detector. The reading of the monitor output signal can be used to correct for any drift or fluctuations of the monochromatic irradiance. Number 6. Non-uniformity and substitution principle. The non-uniformity of the monochromatic irradiance in the measurement plane should be as good as possible. The purpose of the reference device is the correct determination of the spectral irradiance which illuminates the device under test. Non-uniformity of the monochromatic irradiance generally falsifies this measurement. If the non-uniformity is reproducible, it shall be measured, leading to wavelength-dependent non-uniformity correction factors. If technically possible, it is recommended to determine the average spectral irradiance by scanning with the reference detector the entire area illuminating the device under test. Number 5. Reference plane. The monochromatic light usually is not collimated but divergent. In consequence, the spectral irradiance decreases with increasing distance from the light source. Therefore, it is of importance to measure the device under test and the reference device exactly in the same plane. Number 4. Choice and operation of bias lamps. Solar cells and other detectors can generally be nonlinear devices. This means that the spectral responsivity can be different at low and high irradiance conditions. Therefore, bias light is applied for the DSR calibration. Since the origin of nonlinear behavior in the device under test are often defects, and since these defects can be sensitive to special and generally unknown wavelength bands, it is advised to use broadband bias light sources such as halogen lamps. The spectral irradiance of the bias lamps shall be matched to the light source the device under test will be exposed to in its final application. Additionally, it is advised to use power supplies for the bias lamps with low noise and ripple, so that there are no fluctuations in the bias light that could falsify the lock-in signal. Number 3. Measurement electronics. The chopped monochromatic irradiance generates an AC current in the device under test and in the reference device. The bias irradiance generates a DC current. Usually both devices are electrically connected to a transimpedance amplifier by 4-wire connection. The transimpedance amplifier shall keep the devices in short circuit state and converts and amplifies the current into a voltage. At the same time, it shall split the output DC voltage and AC voltage into separate outputs. The AC voltage is then electrically connected to a lock-in amplifier. The DC voltage is electrically connected to a voltmeter. If it is technically feasible, it is advised to use the same transimpedance amplifier and lock-in amplifier and the same settings and measurement ranges for both the measurement of the device under test and the reference device. In consequence, all amplification factors cancel out during data evaluation and hence do not need to be determined. Number 2, wavelength calibration. The spectral responsivity of the device under test shall be measured as a function of wavelength. Therefore, the centroid wavelength of the monochromator output must be known for each wavelength. This can be done by placing a calibrated spectroradiometer in the measurement plane where the device under test usually is located. The spectroradiometer shall be calibrated with respect to its wavelength scale and with respect to spectral irradiance. The wavelength calibration of the DSR facility shall be done on a regular basis, depending on the reproducibility of the monochromator. And it shall be done after each realignment of the optical setup of the DSR facility. Number 1, overfilling. Overfilling means that the light field is larger than the area of the photovoltaic device. A solar cell is generally used under natural sunlight, which overfills the solar cell. In consequence, also the DSR measurement shall be done overfilled. The size of the monochromatic light field in the measurement plane must be larger than the PV device. This not only includes the solar cell, but also all parts of the solar cell package that could couple light onto the active area. These were the top 10 of things to be considered when operating a differential spectral responsivity facility. Thanks for watching. If you like this video, please subscribe to the YouTube channel of PTB.